see, share the screen. So, okay, so I'm going to be talking about teaching Prolog and logic programming, I guess, over my now 30 plus years of teaching it, and since 1986. On the cover of the CACM, where, I think you had the Japanese standing on each other's shoulders. I still have the image somewhere, and reaching to a rocket that was suspended in the air above. And I guess ACM was an American organization then, and the Americans sort of falling on each other. So that's when I learned about FGCS, and I came to know that it's actually, Prolog was a central part of it. So that was actually, quite inspiring, and that prompted me to come into the, take up logic programming as a field of research. So when I arrived in graduate school at North Carolina, then there was a big functional programming group, and David Plaisted was there in theorem proving. And actually, they offered a class in 1986 for the first time. This is spring of 1986, where I took the first class in Prolog and logic programming, taught by, you can see these three illustrious folks, as you get the pointer. So David Plaisted, of course, is very well known. Bharat, many of you know, but Bruce was actually a PhD student there, I believe. But he was immensely interested in Prolog. Unfortunately, he passed away a few years ago when, he went in industry and was a practitioner. So this course actually taught a third of it was theorem proving, classical theorem proving based on, sort of Chang and resolution theorem proving, Herbrand's stuff and all that stuff. 1/3 was Prolog programming taught by Bharat. So theorem proving was taught by David, and then Prolog programming was taught by Bruce, because he was super Prolog programmer. I mean, even though these are early days. And 1/3 of it was taught by Bharat, which was implementation. And that's where, the trail and the heap and the stack and, WAM was introduced very peripherally. And I learned about WAM much later. So then that, inspired me to be in logic programming. And I did my PhD in parallel logic programming, subsequently joined David H.D. Warren's group in Bristol. And then, after finishing there, luckily, I got a faculty position at New Mexico State. And in fact, I was recruited and I was actually looking for a job in England, in the US, because they had just gotten an NSF grant to teach logic programming to freshmen. And they did not have anybody who was a logic programming expert in the faculty. So they saw me as a person who knew logic programming, Prolog, and so they recruited me. So, all these odd ways in which one can actually land a job. I was very happy to actually land a faculty position. So I got involved with this project and taught logic programming to freshman students. And I think their main insight of this group, which had already actually gotten the grant, was that with Prolog, you can sort of get into serious programming on day one. So you could teach database programming right away, right? And lots of other things. And then you can teach recursion, which is a better way of teaching programming. And so this course then devolved into, this was a 2-semester sequence, 1/3 Prolog right in the beginning, 1/3 of functional programming, and then 1/3 of imperative programming. And actually it was a reasonable success, and it ran for many years. And students were actually taught that way. But, once the people were gone, left, then, sort of stopped. So unfortunate. But I would say it was a great success. And also actually help inform my research, because one of the things that came to my mind was, how do I model circular linked lists, that you teach later? But, people ask, well, what about circular linked lists in Prolog? This actually led to, so I thought, when I learned tabling later, I thought tabling would be able to handle circular data structures. But it turned out actually that, you need this co-inductive logic programming, which we actually got to work on and still continue to work on today. So 1992, I started teaching logic programming to grads and seniors at New Mexico State. And then 2000 moved to UT Dallas, and the logic programming course still continues to this day. So I've basically taught it every year since 1992. I followed the same structure that I had learned, though cut back a little bit on implementation aspects, because not everybody was interested in the implementation details. So now the course has evolved a little bit, with ASP gaining prominence, plus my own forays into ASP through SCASP. And so essentially theorem proving is gone and replaced by answer set programming, Klingo, and SCASP programming. And, also the logic programming class has been, the students have been a guinea pig for me to test the SCASP system as we have developed it over the year. So why teach logic programming and answer set programming? Well, it's an important, logic programming is an important paradigm. Of course, knowledge, I'm probably preaching to the choir here, knowledge must be passed to the next generation. And for me, I had a selfish interest in recruiting PhD students. So there'll be students taking the graduate class, and at the end of the class, they will, be inspired by logic programming and then come and ask me, well, would you take me as a PhD student? And, that's how I basically recruit PhD students. And that model actually has worked very well and works even better now because, AI is such a hot topic. And in any case, it's good to have students go to industry with knowledge of logic programming. And in fact, I explicitly tell my students, especially, things like when I teach definite clause grammars and those kind of things, that if you have to write a parser, quick parser, write it as a DCG. I don't know if they take that advice or not. So generally, a logic programming course, at least, and I think US campuses, and I'm, sort of, inducing from my experience, does not directly attract students. You have to sort of, advertise it a little bit and tell people of its existence and benefits. Now, recent popularity of AI actually has helped. So I've given presentations. I think that logic programming equals attaining nirvana in computing, right? Really get solid foundational understanding of computing that you cannot get in, I'd say, in other ways. And logic programming is sort of also the grand unifying theory of computer science, in my opinion. So I sort of market this to students, and enrollment goes up. And of course, it turns students into better programmers, better understanding of recursion, databases, etc. And I also teach recursion in the class, of course, you have to. And I use this recursion as magic, that I think analogy that Veronica brought up. And in fact, and I've been teaching it this way for the last, and it actually works quite well and gets, improves students' understanding. Also, there can be local reasons. So for example, here we have the qualifying exam. And one of the things that I'm able to tell students that it'll help you do better, for example, in the AI qualifier. So today, of course, AI reigns supreme and everyone's attention is on AI. So, I use it more for marketing my LP course. So in fact, I'm going to offer it in spring. I already have 27 students. Very likely it will go to about 50. And now that AI is prominent, we really have to educate the general public that intelligent behavior has, two components, not just all about learning, but there's reasoning as well. And I think most people are not able to make a distinction. Even people working in machine learning, many times, they're not able to make clear distinction between learning and reasoning. And reasoning is equally important. So that actually helps draw quite a few students to my class. I mean, my enrollment would not generally go to, this is a grad class, to 40 plus. It'll be more like 20 plus or 30 maybe. But now with AI becoming prominent, I get a lot more students signing up. So, like I said, when I started out, it was 1/3 theorem proving, 1/3 Prolog programming, 1/3 implementation. And I use Shapiro and Sterling textbook, plus Chang and Lee's book, theorem proving book. Today, theorem proving part is gone. Prolog programming is slightly cut back. So, I will not spend too much time, for example, UNIV and, all those kinds of, nitty gritty details, but more time in, some time has gone into ASP, knowledge representation, and also constraint logic programming, which also I think is an important part of a logic programming course. So now I still use Shapiro and Sterling, or Sterling and Shapiro, should be, I guess, chapter 1 through 14 and chapter 19. And then some notes for constraint programming, or CLP rather, I would say. I teach really constraint logic programming, not constraint programming. And then this book by Gelfond and Kahl actually is a very nice book, practical book about ASP, where he actually they show how you can represent knowledge in answer set programming. So it's very nicely done. And actually, in fact, Michael has written actually a book with his daughter. So his whole family is in ASP, which is quite incredible. So today, essentially, I'll cover topics like logic, of course, logic programming, constraint programming, the Prolog language, and then a little bit of about reasoning, deductive, inductive, and abductive reasoning, logic-based knowledge presentation and reasoning, non-monotonic reasoning, answer set programming, and then, of course, you bring in common sense reasoning, and a little bit of explainable AI, inductive logic programming, and how you can make AI or machine learning rather explainable through logic programming. And a project is also required. Of course, must be in ASP now and SCASP actually, because, that's what we are building. And as I said, we're using students as guinea pigs to help, improve the system. And actually has helped. I mean, students using the system has helped quite a bit. So homeworks are all done in Prolog. So there are 3 homeworks in Prolog and CLP, 1 around Klingo ASP and 1 on SCASP. And there's a project at the end. And actually, many students do come and ask me for including theorem proving, but there is really no room. So enrollment can go from anywhere from 25 to 50 in this class. So some thoughts. So a course in logic programming today has to be couched in knowledge representation and AI, I would say, to attract students. And there is growing realization that reasoning is essential for AI. So if I just offer a course on, say, logic programming and Prolog, I will definitely get students. But if I, want larger number, get the gospel out, then I have to essentially use the crutch of AI that, it's useful for AI. So of course, we need to connect logic programming and answer set programming, which I also, which is basically logic programming, with the current AI wave. It will help us as well as, help, of course, AI. There's a lot of attention being given to neurosymbolic AI, which is, combining essentially reasoning and machine learning, sub-symbolic AI and symbolic AI, as well as explainable AI. So these things actually help in making, I think, logic programming technology more prominent, more popular, and attracting students for the course. So some more thoughts about, pedagogy. It'll be good to have a common set of slides. And I think this group has already been working on it, right? So Hector Levesque has a nice set of slides that accompany his book that I actually have not used, but I plan to use. And then for answer set programming, Gelfond and Carl's book actually comes with slides, but they're very superficial and high level. So I actually need to work on making, more detailed slides on this book. Hopefully will happen one of these days. So, but I prefer writing code on the whiteboard. So especially for Prolog, because actually I can do it. ASP, I, need a little bit of help. I have to look up things. And again, we should build a repository of course material, which already is being undertaken by this group. Now, one thing that I have done is to organize hackathons around logic programming to sort of spread the gospel. And also some of it is, again, get SCAS to be, more popular and more used. And so I have organized 3 hackathons so far. Last one was in 2022. So I was actually doing it on World Logic Day on 21 and 22. The first one was in 2016. And I plan to actually organize one in January of 2024. So 2023, I somehow just did not have the energy because I was traveling. So the idea here is that I will teach logic programming and answer set programming for about 5 hours. So hold 2 workshops, 2.5-hour duration, 2 of them. And this could be anyone. As long as they know data structures, they are welcome. Actually, don't even know data structures. Okay, just come in. And then they participate in the hackathon, which runs for 24 hours. And then there are 5 or 6 mentors, people who have taken my course or people who are interested. And me and my PhD students, we actually help them. We get about 60, 70 students participating. It starts out with maybe 80, 90, but drops. And then some interesting things actually get done. So here's an email from one of the students who actually participated in 2022. So these are the things actually that can have more impact. So I don't know if you can read the email. It says, my name is whatever. Yes. I used your research in, I attended Hack Reason 2022 and got 2nd place. And I actually used this research in answer set programming and in Fannie Mae Challenge. My project used SCASP to automate reasons why one may not qualify for a home loan, et cetera, et cetera. So in fact, I'm talking to him. This is actually January 10th. So I'm talking to him tomorrow. He's going to show me his project. So you get these kind of things where students get really interested and then they try the system. They're actually using it in other places, and hopefully tell other people about logic programming. Okay, so now the real world. Okay, I have only a few minutes left, and you have seen these slides. So Prolog is used for many consequential applications. So I think I compiled some examples, New Zealand Stock Exchange. So Prolog is popular. I mean, and so we have to continue teaching Prolog and logic programming. Logic blocks, you all know. At some point, Saber's third of all airline was processing third of all airline tickets using Prolog. I don't know if it's still there or not. And I think, and this, some of you actually contributed some of these applications. NASA has a voice control system on board that uses Prolog, apparently. Watson relies on Prolog. US Customs uses, and ProSim actually is a million-line Prolog system used by a Dutch chemical company. It uses if Prolog, actually, which is a legacy Prolog, but they still maintain and use it. And I think this is a project that Bob did for WHO, UNICEF. And of course, we know about Prolog and Symbium, systems for automating legal reasoning, logic process modeling, which was presented at the last year's 50-year celebration, is a Prolog, Stony Brook Prolog-based system. And it still is used by the aerospace industry for 30 plus years. And then there are others, in the software assurance industry. And DNA barcode discovery, I think this was Veronica's project in Canada that uses Prolog. And I have actually, had two spin-offs based on my Prolog research, one for automating porting of programs, where we did have customers from companies like Siemens and GE, but gradually the product actually went through its life cycle. I did not get, I did make some money, but I didn't get, super rich, let's put it this way. And then another one on helping blind people, where automatically translate the, they basically write math in Braille using something called Nemeth Math Code. And Nemeth Math Code actually is a heavily context-sensitive language. So parsing it was considered an insolvable problem. And so, of course, with Prolog, actually, I could do it and translate it into LaTeX, and then you can render it. So the idea was that the instructors can grade what their student has done in Braille. So sighted instructor who doesn't know Braille. So this was also spun out in a company. But again, the problem is there are not too many people studying math using Nemeth, very few people. So I need to make that system actually publicly available for free. Happen sometime, I guess. And then, of course, in my department, actually, we use a Prolog-based system for automatically assigning teaching assistants. So there are 150 courses, not all of them get a TA. And then small, large, TAs have to be split, and you have to match the skill. And there's a nice Java front ends actually being used for 20 years now. Incredible. So everybody, at the beginning of the semester, you input the TA data, you input, and the server, everybody gets an email saying choose your preferences, et cetera, et cetera. And it's actually a CLP, Sixtus-based CLP system, which computes the allocation. So it does not try to maximize happiness, it minimizes unhappiness. And so there are people who are still, unhappy, but it does a good job. And it's been in all cases, Prolog was indispensable, or basically the problem was solvable. And I think some of these things you already know, right? Issues that impact use of Prolog, availability of libraries and development environment, trained Prolog programmers. I think that's a serious problem, that many times people don't use Prolog in the real world because they can't find trained Prolog program. And I had that difficulty as well. My PhD student was in the company. He knew Prolog very well, but the other people, did not. I mean, they were doing other functions. But that is, if you need 10 Prolog programmers, you'll have a hard time finding them. And also, once you train them, and once people leave, including I have seen PhD students, I mean, they once they join industry, then the imperative programming overpowers them. And then they basically somehow, stop believing in the power of declarative programming. And also we discussed, I think at ICLP, that many times companies, if they're using Prolog, and then Prolog is their strategic advantage, they do not want to advertise their secret sauce. So it's sometimes very hard to know if someone is using Prolog or not. And also I think another thing pointed out by a few people, that once you build this, solve the unsolvable problem using Prolog, but then the person who is the Prolog evangelist, their excitement is done. So what do they do afterwards, right? Because the rest of it is going to be boring maintenance and stuff. And then, of course, Prolog's non-logical feature that turn off people. And another problem that, Prolog or logic programming, I guess, education and even, use in the real world that we face is that for most Prolog systems, there is one person who actually maintains it. What happens after them? So I think this was discussed at ICLP. Standardization and portability across Prologs then becomes an important aspect. Okay, so one more slide and I'll stop. So I think ASP sort of, you could say, the elephant in the room, right? I mean, ASP is becoming popular, a lot of prominence gained over the past 20 years. And ASP does support knowledge representation and reasoning applications quite elegantly. And there are many applications that have been developed for ASP, traditionally implemented using SAT solvers, as most of you know, basically only data log ASP allowed. So as a result, you would see that I think ASP is used more for optimization and constraint solving application as a competitor to CLPFD rather than for knowledge representation. So ASP does offer additional declarative expressiveness, I would say, and is an important LP extension. Is there a question or something? So that's where now, we have been working on SCAS, which brings in, ASP within Prolog. So under the umbrella of Prolog, because there is a goal-directed implementation. Also supports predicates, uses co-induction for cyclical reasoning, and now available under Swish, as well as Chow-based meta-interpreter plus Chow Playground. There's a Chow-based meta-interpreter that you can sort of run on your machine. And there are many applications now of SCAS, Rules as Code project in Canada, where it's trying to automate legal reasoning. There's a company in Finland that actually designed treatment automation for diabetes, and they're filing for approval from Finnish FDA. And that's how Jan actually got interested in SCASP and included it in Swish and SWI Prolog. And then there are uses in systems assurance. So, SCAS brings in ASP under the umbrella of Prolog. So I really urge you to, look at it and join and help make it more efficient. And, so a lot of work is still needed. Okay, so I will stop here. And I also had prepared, if I had time, about my take on computational thinking, but this will have to wait for another time. So, okay, so I said went all over the place, said lots of things. I don't know how many of them are related to teaching, probably not all of them, but anyway, some thoughts. So questions, comments?
Thank you, Gopal.